Process Safety and Loss Prevention (PSLP) sections of integrated project is aimed to identify hazards from one selected separation unit from the process flow diagram. Perform hazard study on the study notes of the separation units and the recommendation as well as justification to improve the safety aspect of the separation unit. The equipment chosen is the distillation column, where the separation occurs between acetone and phenol to obtain phenol as the valuable product in the plant. Hazard can be defined as the conditions or event that result to severe and undesirable event. In this project, the process safety is focused instead of occupational safety, as students are concerned on process industry rather than workplace scenarios. It is important to perform hazard study on the distillation column, as it is dealing with highly flammable liquids under high temperature and pressure conditions. According to Moran, distillation which is stored in structure filled with heated phenol and acetone are hazardous, as many serious accident occurs usually at the column and its additional operations. Thus, safety precautions and mitigations need to be planned in advance in order to prevent any loss of containment or casualties. HAZOP is an acronym of Hazards and Operability Studies, and the general purpose of HAZOP is to obtain the detailed risk analysis of chemical process industry. It is a systematic study to identify hazards, where it utilizes brainstorming discussions from deviation in the operation parameters. HAZOP consists of several steps, which include study notes, deviation, causes, consequences, and action plan, where it requires high level of alertness. HAZOP study is conducted to maintain the quality of products after separation by distillation column, to ensure the required composition is reached and the plant reach its production targets. Besides, it is performed to control mass balance and maintain the column hold up.
Distillation column is the most prominent separation unit and the key operation in the industries, especially in petrochemical industries. It can be said as difficult process as it contains flammable heated liquid, which can cause serious accidents to occur at the distillation columns and also during the additional operations. The distillation column, which consists of large inventories of the flammable boiling liquid and usually is under pressure, can cause serious hazards. Distillation column hazards need to be remarked in order to prevent serious accidents from occurring. Distillation column hazards can be categorized into three major factors, which is the first one is the process control, the second one is the equipment factor, and the third one is the abnormal situation. For the first factor, which is the process control factor, the hazards are the overpressurization of the low pressure system, which is caused by the utility failure, excessive heat added, and exothermic reaction can cause an energetic event. Next, the high operating temperatures can weaken the walls of the distillation column and reduce the maximum allowable working pressure. Hence, at high temperatures, it can cause a runaway reaction and lead to operation failures. Next, the extreme low temperature can cause the materials to lose ductility and the distillation column to become cracked. Besides, the auto-refrigeration of the low boiling fluid may occur and result in the blockage of the trays. The next factor is the equipment factor, and the hazards are the failure to properly assemble distillation column components, and its connection can lead to a exposure to the workers in the plant. Besides, it may lead to a release of flammable fluid that result in a flammable exposure in the atmosphere. Next, the reboiler tube leaks development can cause the steam to enter the process and flow into the distillation column. The trays of packing are lifted due to high volumetric flow rate of the gas, and the trays of packing are severely damaged. Next, the failure of the connection or spill of the flammable liquid or vapors cause the flammable exposure of the vapors and liquid in the enclosure. The last factor is the abnormal situation, which the first one is the failure to set low pressure of nitrogen supply cause the atmosphere to be lacking of oxygen and lead to exposure to the workers in the plant. The next one is the deposition of the flammable material on the picking surface lead to fires when the distillation column maintenance is done. And the next one is the high flow rate of acetone feed into the distillation column cause the process to be upset and overwhelm liquid to gas separator.
For stream feed, when there is no flow, it is mainly due to the pipe being plugged, broken or control valve fail closed. So this actually leads to undesired output where low level in the distillation column. So to overcome this, install low level alarm and control valve fail open. For less flow, it is mainly due to pipe leakage partially plugged or control valve partially closed. So this leads to backflow of material and all specification product. To overcome this, install high flow and level alarm and control valve fail close. For more flow, it is caused by the high pressure supply and control valve fail open. This actually leads to distillation column overflow or flooded with the solvent. Tools to overcome this, install high flow and level alarm and control valve fail open. Tools, the actions need to be taken is install check valve, low flow alarm and add lock procedure to the valve.
So basically, safety precaution and measures is very important in order to avoid any unwanted or abnormal situation that can lead to many dangerous events such as fire, explosion, rupture of equipment and many more. So basically, there are four recommendations that we have made to our project, which is the installing emergency pressure relief device, alarm control system, interlock strategy and the valve failure position. So, for the first recommendation on the distillation column unit is to install the emergency pressure relief device such as bursting discs, vents as well as the relief valve. This is important in order to release any built-up pressure that contained within the column that is due to the loss of reflux or any block flow of the overhead vapors. The second one is the alarm control system, which is implemented in order to provide notification and warning alerts to the operators and the personnel of the plant regarding any abnormal situation that arise. The third one is the interlock strategy, which is to monitor the pressure level by its feature of mutually dependent variables. And the last one is the valve failure position, which is encompassed of fail close as well as the fail open to control the supply energy and flow to meet the desired production of phenol. So, I will now conclude about our overall project of production of phenol from Cumene in regard to the process safety and loss prevention part. So basically, distillation column unit has been selected for further analysis and identification of possible risks that can be resulted due to any deviation from our study notes. So basically, this distillation unit column appears to be the most crucial and important equipment in our plant, as it can impose a large potential hazards to that can lead to many dangerous accidents such as fire, explosion and many more. So basically, flow and composition parameter were given the major concern in these hazard studies because the deviation that arise can contribute to many unwanted events such as overpressure, product of specification, explosion, fire and rupture damage to the equipment. So basically, few recommendations were made with justification in order to enhance the safety assurance and precaution such as the alarm control system, pressure relief device, interlock strategy as well as the valve failure condition. So basically, that recommendation is very important to enhance the safety effects in distillation column.